Let us continue with software architecture. We have many different architectural styles, just as architectural styles for the houses that I have shown you on the former slides. So we have also various architectural styles for software systems. I won't be able to present them all, but I can give you some examples so you have some idea of what styles do we have. Here is one style which is called project repository. It is a database based style where you have a central repository and and you have various applications that communicate with each other via this central repository. So the style is called repository model. Subsystems exchange information via common repository. So all data is shared by all these applications in this central repository. And the data that is generated by one subsystem is then used by other subsystems or applications, if you wish to use this term. We have also client-server model, and it is organized as a set of services and associated servers and clients that access and use the services. Most of you are acquainted with that. Architectural style that is called layered architecture means that a system is organized into a series of layers where each of them provides a set of services for the next layer. So you always communicate with the system, or the layers communicate with each other. Never ever the layers should communicate, the front levels should communicate with the lowest levels, because this may imply some problems. So changes, there are many problems related to it. I don't have time on this course to discuss it. This is the stuff that should be presented by design courses. But one of the ideas behind all this is that when you make changes to one of the layers, so only this layer will be affected by change and the closest layers, but you don't need to go through the whole system in order to make the changes. And also by assessing the next layer, you promote some kind of security of the system, because the users won't be able directly to access the lowest level, in this case the database, and make changes there. We have also data flow architecture, which is also called pipe and filter style, where the system contains a change of functionalities, where output of one functionality is input to the other functionality, and they process like that, so till they come with a result. So there are many architectural patterns. What is important is that you have to be able to determine what kind of architectural style your system is going to have. It is to design the system is a very difficult process. It's a creative process. You have to have good abstraction capacity. And of course, everything depends on what type of a system you develop. So you will have to make a number of decisions. Some of them are, before you start creating any architectural design, you must check whether there is any generic application architecture that you can reuse. Either something that is available to the public, or maybe there is some architectural design that may be reused within the company. You will have to check how the system is going to be distributed. Is it going to be developed on one node, or is it going to be developed across several nodes? You will have to identify what architectural styles are appropriate. So you will have to choose a subset of them, and out of this subset you may choose only one. Or you may use several styles for one and the same system, where you have one style for the whole system, and then each subsystem may follow different architectural styles. You will have to find out what is best just for your system. You will have to know how the system is going to be decomposed into subsystems or modules. This is a pre-observed, it's a creative process, so you are the one who determines how you are going to decompose your system, and also to define what kind of control strategy should be used. How is the system going to be controlled? Is it going to be controlled centrally, or is the control going to be distributed? How are you going to evaluate your architectural design? You know, some architectural designs may be evaluated from various perspectives, like maintainability perspective, how easy it is to maintain the system, or from the performance perspective, how fast is the system, or other aspects. And you will have also to decide how to document the design. There are many different activities you conduct while designing architecture and while designing systems. What is important when you design the system is that you have to define what are the boundaries of the system. In our university management system, we have to decide, are we going to have subsystems that deal with course literature, or is it outside our system? So you will have to make this decision, and this is you who is going to decide it. You will have to model the system structure. How does the overall structure look like? I have shown you an example of a block diagram. You will have to model how the subsystems interact with each other and how they behave. And there is no sequence between these activities. These activities may be interleaved with each other. I have a very simple process model for how to design the system. So of course you define requirements, and afterwards, or while you identify requirements, you create logical architecture. Logical architecture is a conceptual model of all the systems and of the subsystems that are included in the architecture and how they are related. But logical conceptual design is not the same as physical design, that is how the system is going to be implemented. Some subsystems may be distributed over several nodes, where one part of a subsystem may be in Vietnam, the other one may be in the United States or so, or they may be implemented on various physical nodes or platforms, and this is what you decide afterwards, after you have created logical architecture. Of course, while creating architecture and while implementing it, you may be forced to make architectural changes, or even when you deliver the system, you will have to conduct architectural changes, and then you will have to implement the architecture. That is when you implement the system, and afterwards you test the whole architecture. So this is the order. It's a logical order, but this order is actually dependent on the context itself. And finally, you have to document architecture. Not many companies document the architectures. Usually they have a graph, a picture of the overall system design, and then they don't have anything more. I have happened to see such an architectural design. It is important to document it, because this is one way of facilitating the understanding of the system. So what you have to document the static structure, what are the subsystems, what are the components, so you define them. You have to describe the dynamics of the system, how the system is organized into processes in runtime. You have to provide interfaces, define what kind of interfaces there are between the components. So here you define the services that are defined by each subsystem. You will have to describe the relationship between the subsystems, that is how the data flows between various subsystems, that is how these subsystems communicate with each other. And finally, regarding the physical design, is how subsystems are going to be distributed across various computers.